Welcome everyone. This is our finding the roots of polynomial using synthetic division lesson. We're probably going to see this somewhere in our next quiz or test, and also if you have any questions or comments, please leave a comment question below. So yeah, we learned long division and now we're using synthetic division because it's way easier though. So let's take a look at a possible question we'll see maybe later on. For p of x equals x cubed plus 10x squared plus 11x minus 70, find the roots when x minus 2 is a factor. Okay, so the very first thing is that if we're told that that x minus 2 is a factor, that we're going to set that factor equal to 0. All right? It's kind of like when we do quadratic equations, and when we factor them and each factor equals 0, we solve for x. So very the same way, we're going to set x minus 2 equals 0 and then solve for x to get, in this case, x equals 2. But now what? Okay, well, we know one factor polynomial. We can then find the matching root by setting the factor equal to 0 and then solve for x, which is what we did. We'll then use that value of x to perform a synthetic division. We can then find the remaining roots by either factoring or using the quadratic formula. And I say this because after we divide using synthetic division, we're going to get a quadratic equation. We're going to set a quadratic expression which we'll set equal to 0. And then again, we are able to either factor or we can use quadratic formula to help solve. So let's set up our synthetic division, and so we'll put the root 2 in the corner, and then fill in the coefficients in this case for 1x cubed plus 10x squared plus 11x minus 70. So we have 1, 10, 11, and negative 70. We leave a little space in between equal bar, and so now synthetic division. We always bring down the first number, and from there, any number we find, we're going to end up multiplying by the root, and then putting that product onto the line there. So 1 times 2 is 2, and from here we're going to add. So 10 plus 2 is 12. 2 times 12 is 24, so we put that up here. We add downwards. We get 35. Then 2 times 35 is 70. And negative 70 plus 70 is 0, which is exactly what we want, because if x minus 2 is a factor, we should see in this case there's no remainder we divide. Now sometimes it's good to put the actual variables, exponents, above the coefficients we use for synthetic division to remind us what they were before. So here's x, and 70 was a constant. Now to find the quadratic expression, the numbers will get the variable with the exponent that's 1 less than before. So we have 1, 12, and 35. So instead of 1x cubed, we get 1x squared. And plus, instead of 12x to the second, we have 12x to the first. And instead of having x, we have the constant. We then set this equation equal to 0. Now we have 1x squared plus 12x plus 35. We can factor, or you solve by quadratic formula. So let's see. Are there two numbers that multiply 35 and add 12? Well, I think so. 7 and 5, because 7 plus 5 is 12, and 7 times 5 is 35. And so we are going to now put x and x here, so those are factors. We then set each factor equal to 0. So we have x plus 7 equals 0, x plus 5 equals 0. And then we solve for each x value, and we get x equals negative 7, and x equals negative 5. Okay? Now, our roots, there are 3 of them. We don't want to forget. We have x equals 2, x equals negative 7, x equals 5. So we'll make a statement here on the side. The roots of p of x are x equals 2. Sorry, my handwriting's terrible. X equals negative 7 and x equals negative 5. And you want to kind of box your answer tells teacher, hey, this is where my answers are, focus here for your answers, and then of course look at the rest of this work, okay? Let's look at another example. Find the roots of q of x equals 2x cubed plus 3x squared plus 17x plus 12 when one factor is x minus 1. Like before, we're going to set x minus 1 equal to 0, and then solve for x to get x equals 1. This is our first root and will be what we use to multiply when we do syntactic division. Now for our coefficients. So for 2x cubed is 2, just writing down the coefficients, don't worry about the variables. Okay? And again, I'm going to put the x cubed up top above the 2, the x squared above the 3, the x above the next 17, and the letter c for constant for the 12. Draw the equal bar, and then we're just going to bring down the 2. First step, always going to bring down 2, then multiply by the factor, which is here's 1. 2 times 1 is 2. And then we add, 3 plus 2 is 5. 5 times 1 is 5. Neg 17 plus 5 is neg 12. And then 1 times neg 12 is going to be neg 12. 12 plus neg 12 is 0. Again, confirming that we have done this correctly. Okay, so now we will get the quadratic equation of 2x squared, remember it's one less than the previous one, plus 5x minus 12 equals 0. And so we want to see if we can factor this now. So, okay, well, we definitely multiply the 2 and the neg 12, so a times c equals neg 24. Okay, and in this case, are there two numbers that multiply to neg 24? And those same two numbers will add to 5. Well, see, neg 24 is, well, definitely 12 times 2, okay, but that's not going to work out so great. Maybe 8 times 3, and that might work out, because if we do positive 8 and negative 3, that gives me neg 24, and positive 8 plus negative 3 gives me the 5 here. Now, unlike before, when we have a value that's greater than, a value is greater than 1, we're going to replace the 5x here with the numbers 8 and negative 3. So I'll put down here neg 3x, 8x, and then 2x squared minus 12 equals 0. And use not long division, sorry, I meant factor by grouping. So let's group this together. And we're going to get, in this case, greatest common factor is x. We're left with 2x minus 3. Between 8x and neg 12, the greatest common factor is going to be 4. And we're left with 2x minus 3. And again, we have factor GCF, again, is 2x minus 3 because our GCF is a binomial. And we're left with x plus 4. And when we set this equal to 0, we can then set each of these factors equal to 0. So 2x minus 3 equals 0, x plus 4 equals 0, and we'll move down a little bit here, and we'll solve. We're going to add 3 on both sides. 2x equals 3, x equals 3 over 2. Subtract 4 on both sides. X equals neg 4. And so our roots are going to be x equals 1. Don't forget the first one. X equals 3 over 2. And x equals neg 4. Okay? I'll make this full page. You guys can take a look here. Okay? All right. So just a reminder, if you find this video helpful, please give it a like. And if you have not subscribed to the channel yet, please subscribe. Really appreciate it. And again, leave any questions or comments in the comment section below. Really appreciate hearing from you guys now. Let's try one more problem. So find the roots of k of x if x cubed plus x squared minus 5x minus 6 when one factor is x plus 2. So we do the same thing we normally do. X plus 2 equals 0. Subtract 2 on both sides. Our first root is x equals neg 2. Where their coefficients are 1, 1, neg 5, and neg 6, again, we'll put the x cubed, x squared, x, and constant. Break down to 1. 1 times -2 is -2. 1 plus -2 is -1. -1 times -2 is going to be 2. -5 plus 2 is -3. -3 times -2 is 6, and -6 plus 6 is 0. Again, we know we have now factored properly. But now we get a quadratic equation that's 1x squared minus 1x minus 3 equals 0. There's no numbers that multiply to 3 and subtract to 1, or -1, so we have to use quadratic formula. So we're going to find our a value, and it's so funny in this case, our a value, our b value, and our c value are already set up for us. So we know here a is 1, b is -1, and c is -3. Okay, again, the nice thing of having synthetic division, you know, we're not messing around with any of the variables now. So, okay, so now we use quadratic formula, and our formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Now let's plug in. So x is equal to negative of -1 plus or minus the square root of -1 squared minus 4 times 1 times -3 all over 2 times 1. Well, we see here -1 squared is 1 minus 4 times 1 times -3 is going to be -12. So -1 minus -12 is equal to 13. Okay, so we get x is equal to -1 is +1 plus or minus the square root of 13 over 2. And so that's two roots because you have 1 plus square root of 13 over 2, 1 minus square root of 13 over 2. And the other roots are x equals -2. So these are the roots of our polynomial. Okay, and there you go. Makes a full page, you guys see. So here we see we can even use quadratic formula to help solve for finding the roots. It works whether it's not factorable or even factorable. So just keep in mind that that's always available to you guys. All right, ladies and gentlemen, again, hope this was helpful to you guys, and look out for other videos. We're working on polynomials, especially with quadratics, and you know, I look forward to hearing from you guys. Really appreciate if you could. It just takes a little bit of time. Just hit that like button, and it really helps our channel though. All right, thanks so much. I will see you in the next video. Take care, everybody, and be safe.